All right, so now that we kind of have an idea of what the absolute value function looks like, why don't we take a look at more specifically how we find the ordered pairs on the graph and how we graph this. So our first question, example 1, we're going to graph the absolute value function. And what are the features of the graph of f of x equals the absolute value of x? So let's get some ordered pairs. We'll plot some points and see how this looks, and then talk about a couple things, domain, range, a couple of our key features. So we are going to take this -2 for x, and we're going to plug it into our absolute value function. So we're going to take the absolute value of -2. That turns into a +2. And then we have an ordered pair where the x that we plugged in was a -2. And then the value that we got back for our function is a +2. So that ordered pair is on our absolute value function. Now we're going to do the same thing with the -1. We're going to take the absolute value of a -1. Absolute value of a -1 turns positive to a +1, and that ordered pair, the x value we plugged in is -1, and then the y value, or the function value that we got back, is +1. All right, we're going to just continue on plugging in these values. We're going to take the absolute value of 0. Absolute value of 0 is just 0. So the x value that we plugged in is 0, and the y value, or function value, that we got back is also 0. All right, our next x value is the absolute value of 1. Absolute value of 1 is 1. The x value that we plugged in is 1, and then the function value we got back is a +1. And last we have the absolute value of a +2, which is +2. The x value we plugged in is a 2, and then the y value, or the function value we got back, is a +2. So let's go ahead and graph these ordered pairs and kind of see how we get that shape of our absolute value graph. Our first ordered pair is -2, 2. So from the origin, I'm going to go to the left 2 and up 2 and plot a point right there. Then we're going to go -1, +1, so to the left 1, up 1. We've got 0, 0. We're going to go to the right 1, up 1, and then to the right 2, up 2. We can go ahead and draw in our lines here. Absolute value graphs have a V shape. So anytime you're graphing an absolute value function, we know what it should look like. It should take the shape of a V of some form. It might be transformed a little bit, but it will have that V shape. So let's tie in some of that vocab we saw in our last video. We know that this point 0, 0 is the vertex. That is the lowest point on this function. I also could draw in the axis of symmetry. That's going to be the symmetry line that cuts your graph in half. We often draw this in as a dotted line because it's not officially part of the graph, but it's just, it gives us a line of symmetry. It helps us find some key features of our graph. That equation is x equals 0. But the absolute function, or the absolute value function, is just the V shape. Okay, let's talk about the domain and range of our absolute value function. So if you remember, the domain represents our input values, which with functions with x and y, that is our x values. So the domain is our x's, right? So let's think about what x values will this function have. If you look at the function itself, absolute value of x, can we plug in any x value? Can you plug in negative numbers, take the absolute value? Can you plug in a 0 and take the absolute value? Can you plug in a positive numbers and take the absolute value? And yeah, mathematically, you can plug in all those numbers for x and it'll work out. In our graph, what we notice is that all the x values heading to the right, so remember x's go left and right, as we head to the right, this graph will eventually, even though it's going up, it's also going out. It will eventually hit every single positive x value. It's hitting 0 right here, and as we move to the left, it will eventually hit every single negative x value. So the domain is just basically all the numbers. And so what we say is all real numbers. All right, so then let's have a conversation about the range. Remember, the range is the output values, also the y values, or because we are in function notation, we also could say the f of x values. So if we take a look at our graph, I think it's a little clearer to see this. The output that we get, because it's an absolute value, what does the absolute value do? It turns all your numbers positive, right? So if you plug in negative numbers in your input, it gives you positive values back, where all these y's are positive. If you plug in a positive x value for your input, you're going to get back positive numbers. The 0 is not positive or negative, but we saw over here, if you input a 0, you get an output of 0. So that 0 is part of our range. But with our parent function, this V shape, it's never going to come down here and hit these negative y values. So the way that we write this, basically your range is going to be 0 and all of your positive numbers. Your range just won't be negative. So we can write this in a notation that looks like this. We do a little bracket, and we're saying the range is all of the y's such that, maybe let's make a little note. That little line, when we're reading it out loud, we read it as such that. So the range is all the y's such that your y's are greater than or equal to 0. And that is one way to represent your range.